All right, so we are going to finish up this 6.2b, and I think the last thing that we talked about was a parallelogram. No, we did a was it a rhombus or a parallelogram? It was a parallelogram, right? Yeah, parallelogram. And what did we learn? What was the last theorem that we learned about it? Okay, what do the diagonals do on a parallelogram? They bisect each other, exactly right. Okay, they bisect. It's easy just to say they bisect each other, so let's say that. All right, so here's a good old parallelogram. Oops, I got to click off of that. And we are going to draw the diagonals of this parallelogram. So there's one diagonal, right? You go from one corner to another corner, that's a diagonal. And that's a diagonal right there. And so we learned yesterday, I'm not going to put all the letters and stuff on here, because we're going to do an example in a second. So we learned that this little segment and this little segment right here are equal to each other, and this one right here and this one right here are equal to each other. Okay. Now, did we say that the diagonals were equal to each other? No, we never said that, because it's not true. It's not, I should say this, it's not always true. There are cases where it's true. Did we, yeah, we haven't got there yet. We haven't talked about a rhombus yet, have we? No. Okay. We'll get there, but not today. So here's a diagonal, or here's diagonals to a parallelogram, and they bisect each other, which means this one splits the other one in half, or vice versa, right? So they both split each other in half. All right, so this is equal to this is equal to this. So obviously, if I told you this was 5, what would this one be right here? That would be 5, okay? If this was, I don't know, 3, what would this one be right here? That would be 3. You get it? Good. Let's draw another parallelogram. This is the example in the book. This is example 1. I'm going to try to draw it. I'm going to slant it the other way because the book slants this the other direction, like that. Okay? And we're going to draw some diagonals here, and they give you a bunch of information. They ask for you to find a bunch of stuff. This is the kind of stuff you'll see on a quiz or a test, all right? So this is what you really want to pay attention to. Let's call this ABCD. And they do tell you that it's a parallelogram, so it's given. I don't know if they actually use the word given, and I didn't in my notes. I don't have the book in front of me, but I don't know, somewhere in there they probably say this is a parallelogram, all right? Anybody got their book open? Nobody? All right, anyway, example 1, it probably says that it's a parallelogram. So I don't know if they say the word given or not, but I'm going to put that in there. So given parallelogram ABCD. All right, so what do you know about, if they tell you that this is a parallelogram, there's a bunch of stuff that we already know about it, right? Just without putting any numbers in here or anything else, there's a bunch of stuff that we know about it. What are some of the things we know? By definition, what's true about BC and AD by the definition of a parallelogram?
Equal opposites?
By definition. They're parallel, thank you. Okay, it's got the word parallelogram in there, right? Or the word parallel in parallelogram. So the definition says that the opposite sides are what? Parallel. So BC and AD are parallel. AB and DC are parallel. Very good. And yep, and we also said something else. We had a theorem. Now, that was by definition, okay? By definition, we know that the opposite sides are parallel. There was a theorem that talked about the opposite sides as well. What did that theorem tell us? We did that yesterday. What do we know about the opposite sides? What do we know about the length of BC and the length of AD? They're equal to each other. That's right. So this and this are equal. Agreed? Okay. What do I know about the length of AB and DC? They're equal to each other, okay, because the opposite sides are equal. Let's see, what else did we learn yesterday? I'm looking at my notes. There we go. We learned about some of the angles, didn't we? Let's just talk about big angle B right there. Now, there are 2 angles here. Well, there's actually 3. There's this one, and the whole one. But just talk about the whole angle B. What's that equal to somewhere else on here? What else is equal? Angle D, that's right. So angle B and angle D are equal to each other. What else is equal to each other? That's right, A and C. They're equal to each other as well. All right, so that big angle A and this big angle C, they're equal to each other as well. Is there anything else that we talked about yesterday? I don't believe... Oh, okay. What about A and B? What about angle A and angle B? They're supplementary, that's right. Why are they supplementary? Because you got two parallel lines cut by transversal. These are consecutive interior angles. We discussed that yesterday. All right, enough of that. So let's do this. Let's scooch this over just a little bit. Yeah, I guess now it's going to... Let me just get rid of that. Did I do it? That's all right. No big deal. I'm just going to scooch it over so I have some room to write. Okay. Remember, this is parallelogram, so all that stuff we know about it. Now, here's some specific stuff about this particular parallelogram the book gives us. So they actually tell us a bunch of stuff, but there's still a lot of things that we can still figure out. They tell us that AB is 6.3. I'm going to write all this stuff down that they tell us. They tell you that AE is 4.2. They tell you that BD... What are these? What's AB, AE, and BD? Are they angles or what are they? What is it? Okay, well, they're not necessarily sides. By the way, there's an E right here. They're not necessarily sides, but they're what? If there's just two letters, it means it's a what? Line segment. Very good. Okay? It's a line segment. That's what I was getting at. All right, so they tell you some stuff about some line segments, and they tell you a few things about some of the angles. So I'm going to write angle ABC is equal to 72 degrees. This is stuff that they tell you, okay? There's no way we could have figured this out without them telling us. ACD is 63 degrees. And angle ABD, ABD is 41 degrees. Do they also tell you that, let's see, did it AD? I think they tell you one more thing. I think they tell you AD. I'm just going by my notes. Sometimes my notes are a little sloppy. So, but I think they also tell you that AD is equal to 8. Okay? Everybody with me? All right, that's all the stuff that they tell us. We'll put it on the picture here in a second. All right, let's just find out what we want to find. So here's what you want to find. Let's do this in a different color. That's all right. All right, part A says you need to find DC. So that's one of the things we're going to try to find. Part B says we're going to find EC. Part C says we're going to find ED. ED. That's all right. They'll figure it out. And then part D is angle DAB. So they ask you 6 different things. Angle ADC. Well, we haven't got there yet. We're just writing all this stuff down. I haven't even started thinking about solving for it. And then F, they ask for angle DAC. That's a lot of stuff. I wouldn't give you one question where I ask all 6 of those, right? But, hello?
Yes, hello?
Yeah, you called me.
No, you guys keep calling here.
Nope, nobody's touching a thing. Was a little sassy, wasn't it? All right, so here we go. I don't even know where the call button is. Do we have a call button here? Is behind that thing? Okay. I mean, that hasn't moved. Nobody's touched it, so I don't know. Here we go. All right, ready? Let's mark some stuff. AB is 6.3. AE, where's AE? This little bit right here, that's 4.2. BD, that's a whole thing, which is 11.6. How am I going to do that? I'm going to do one of these things. BD is 11.6. All right, AD down here is 8. All right, I'll tell you what, let's use a different color for the angles. ABC, that's that whole big angle right here. Okay, that's 72 degrees. ACD, that's this little one right here. That's 63 degrees. And ABD, that's this little one right here. I'll put 2 arcs just to show it's different than that. So this one's actually the whole angle, right? But this one is just this bottom part of that whole angle. And that's what, 41 degrees? Yeah, that's a little confusing, but you get the idea, right? The whole thing is 72. This part from here to here is just 41. All right. Well, let's use another color. Let's use this. Never use this. Let's use this orange color. All right. So let's see what we can find. DC. Let's find DC. Oh, that's easy. No math involved. What's DC equal to? 6.3. That's right. How did I know that? Because the opposite sides are equal. That's right. So that's 6.3. So that was easy. Agreed? EC. EC. Where's EC? From here to here. Okay. What is it from here to here? How'd you know that? Because that diagonal is being what? What's the word? It's bisected. Exactly right. All right. That's what I want you to know why these things are true. All right. That's why I harp on that. So look, this whole diagonal, it's split in half. So if this is 4.2, then this has got to be 4.2 because it's split in half, right? And you know one of the halves, the other one's going to be the exact same thing. So that's 4.2. Wow, that was nice. No math at all so far, right? ED. Is it going to continue like that? We got to do a little math here. It's not that big of a deal. ED, from here to here. Well, how do I find it? I may not know it off the top of my head. Exactly right. You take 11.6 and 11.6 and you divide it by 2, and that's 5.8. Okay? So you had to do a little math there. So this ED is 5.8. All right? That was easy. The sides were simple, weren't they? All right, let's see if the angles are just as easy. We'll see. Let's pick another color. Let's go green. We're really colorful on this one, aren't we? All right, DAB, where's that? DAB, that's this whole thing right there. That's what I'm trying to find. How do I do that? What is it? This? That's 63 degrees. That's this angle from here to here. It's ACD right here. See, ACD is 63 degrees. So I got to find that whole big angle right there. What'd you say again? Multiply by 2? You can't sit by. By where? Oh, right here? Yeah, you can sit there. Tristan, what were you saying? I didn't hear you. Is it? Did we say that the angle's being bisected here? Nah, we never said that. But we did say that this angle is equal to this angle. Does that help you? Not really, because I don't know that whole big angle. I know part of it, right? I don't know the whole thing. But what did we say earlier when we were reviewing all the stuff that we knew about a parallelogram? What did we say about the consecutive angles? You told me right away, Tristan. You went boom. They're supplementary, right? So look at big angle B, the whole angle B. See that? And do we know the whole angle B? 72, exactly. Right? So what's the relationship between this green one and this pink 72 right here? They add up to 180. Exactly right. You see it? All right. I know there's a lot of stuff floating around all over the place, right? But you got to keep things, compacted. So this whole thing is 180. I'm sorry, this whole thing, this green, is 180 minus 72, which is 108, correct. So this angle right here, the whole big angle, is 108 degrees. That's that. Oh, what did I do? I gave you that, didn't I? That was dumb. Because I'm looking in my notes, I put the answer next to it, and I put it what it was. So now you know what it is, but it probably isn't hard to find. Angle ADC. Pretend you didn't see what I wrote there, all right? So ADC, that's this big whole angle right here. Yeah, this is easy. What's that big whole angle right there? It's 72 because, look, you look opposite, right? You look opposite. Or if you wanted to, it takes a little bit of math, but this one and this one are also supplementary. So I could go 180 minus 108, couldn't I? And I'd still get what? 72. So that big angle right there is 72 degrees. Okay? One more and we're done. DAC. Where's D? DAC. So it's this little one right here. Say that. It's 63? Did we say that this angle and this angle were the same? No. But what is? There is a 63 over here. What is it? It's the other angle. It's this one right here. This would be 63. Why would that be 63? They're not corresponding. They're alternate interior angles. Okay, look. Two lines cut by a not two lines, not just any two lines. Two parallel lines cut by a transversal. Look, this angle and this angle are alternate interior angles. I know it's hard to see because there's so much junk in the way, but this is basically it. There's two parallel lines. There's my transversal. Okay, this one right here. Oh, and now it's the other way, isn't it? Is that right? Yeah, it would be this. Sorry, I didn't draw that right. It would be this one and that right there. Okay, so this is my 63, and then this is the one we're looking for. So look, what's true about this one and this one? They're alternate interior angles. Do you see that? So here's my parallel line, here's my parallel line, here's my transversal, right? Just like this. When you see it like this, it's easy to see. It just pops right up at you, doesn't it? But when you got all that other stuff around there, sometimes it can be a little confusing. So you got to be able to take that stuff apart and say, what makes that 63? Well, this parallel line and this transversal. What makes this angle we're looking for? This parallel line and the same transversal. So these are alternate interior angles. But that's not what we're asking for, though, is it? Angle DAC is not my answer. Yes. How'd you get 45? There you go. All right, so this angle right here, okay, that double green one right there, this one was 63, but the whole thing was 108, so guess what we do? 108 what? Minus 63, and that is 45. So this angle that we're looking for is 45 degrees. Okay? What do you think about that? Looks like you're really smart when you stand back and look at all that stuff, doesn't it? But was it really that difficult?
No, it was actually really easy.
Yeah, I think it was pretty easy, but you got to know your stuff. You got to know the opposite sides are equal. You got to know the opposite angles are equal. You got to know the consecutive angles are supplementary. You got to know your parallel lines cut by transversal, right? We can't forget about those. I told you way back when we first learned that we're going to be using that again and again and again. I think, if I remember right, in my, in my other CP class, and they're considerably behind where you guys are, we talked about the parallel lines cut by transversal, okay, and doing something different. In my honors class, which is, they're a little bit ahead of you guys, not a whole lot, but a little bit ahead of you guys, we also mentioned, so three geometry classes today, we went back in time and we said parallel lines cut by transversal, all right? So it shows up. It shows up, not all the time, but, you know, when it does, you got to remember how to use it, all right? So there you go. Make sense? All right, let's finish up this lesson. Actually, yeah, I got one more example to do, and then we have one more like new thing to teach you, and then we'll go from there. So we got one more example. This is example 2. And guess what kind of picture we're going to draw? Parallelogram. Very good. Oops, wrong thing. Let's try this. There we go. And let's see. Tilt it. I'm trying to make it look like the one in the book. So I think if I tilt that, yeah, that should work. Yeah. And then I'm going to twist it a little bit just to make it look like the one in the book. So that's pretty close. This probably doesn't go down quite as far. Yep, that looks all right. So that's what it looks like in the book. All right. Everything's not just straight across, but that's okay. It's still a parallelogram, right? These two sides are parallel. These two sides right here are parallel. So it's a parallelogram. So let's write some stuff in here. This is J, K, and L, and M. And then they tell you that that side is X. They tell you this side is 2X. They tell you this is 5Y minus 2. And they tell you this is 2Y plus 1. All right, now, the geometry of this is fairly simple, right? Because you know what's true about the opposite sides of a parallelogram. They're equal to each other. So that's really the only geometry you have to know to be able to do this. But the algebra is a little bit trickier on this one than we've had it before, okay? Don't think we've done that. Have we done substitution and elimination in here? Have we even talked about it? All right, because I believe this is the first time. Because remember, I did this with the honors class, and I think this is the lesson where it was the first time we talked about substitution. But you had Algebra 1 last year, right? Yep. And I'm sure you had a great Algebra 1 class, and so you'll probably remember some of this. But I'm going to teach it to you even if you don't remember it, okay? So what are we going to do? We got to solve all the sides. That's what they ask you to do, okay? You want to find all the sides. And, oh, they tell you some things about the angles too. I forgot. It's staring right in front of me, and I didn't even write it down. But let's do the sides first. The angles are super easy. We'll do that last, okay? Give us a little break after we do this next thing, all right? I'm making this to be like it's a big deal, but it's really not that difficult. And I bet you anything that you remember this from last year. Do you remember doing substitution last year where you put something in? Let me give you a super easy substitution. What if I said, I think the word that they used is evaluate. I bet you anything you did this last year in Algebra 1. They said evaluate 3x plus 2 if x is equal to, let's say, 5. Okay, so you did do it. See, I knew you would. All right, so you did this stuff. This is substitution. It's like a simplified version of what we're going to do, but it's substitution. All right, so if you know that x is equal to 5, what are we going to do to find out what this is equal to? Plug it in. That's right. That's what I like to say. Almost every math teacher says that. Did your math teacher last year say plug it in? Yeah. Okay, almost everybody does. So we're going to take what x is equal to. We're going to plug it in for that x right there. Okay? Let's work that thing out. It's going to be 3 what? What's that 3 doing to that x? Multiplying. So I go 3 times what? 5. And then I just finish it off, which is plus 2. And now I just figure it out. 15 plus 2 is what? 17. And there you go. That's substitution. Everybody got it? Okay. Now, we're going to take that a step beyond. You may not have done this in Algebra 1. Probably should have. Just saying. But if you didn't, I'm going to teach it to you right now, okay? Seems like I'm teaching a lot of Algebra 1, aren't I, in this class? Yeah. All right, so let's do this. What do we know about the opposite sides? The opposite sides are what? They're equal to each other, right? So x is equal to what? 2y plus 1. Let's write it down. X equals 2y plus 1. Now, just with that equation right there, can I tell exactly what x is? No, because I got a what? I got a y, and I don't know what the y is, okay? I can't even solve for y because I don't know what the x is, right? So if I have one equation and I have two unknowns, variables, right? That's an unknown, right? If I have one equation and two unknowns, I cannot solve for that equation. Listen to this very carefully. Everybody awake? Listening? If you have two variables, you must have, take a guess, how many equations? Two equations, okay? If I have two variables, I must have two equations with those same variables in it. You with me? Okay. Where's the other equation coming from? You got it. 2x what? Equals 5y minus 2. Okay? This x right here is going to be the same number as this x right here. We call this a system of equations. We're doing this currently in my college algebra class, my 12th grade college algebra class, okay? Even though it's technically an Algebra 1 topic, all right? But this is called a system of equations where these two x's are the same number, all right? Whatever it is. We got to find what it is. And these two y's, guess what's true about these two y's? They're the same number, okay? So it's not like this y is 3 and this y is 5, right? If this y is 3, then what? This y is 3. Got it? Okay. They call it a system of equations. What we're going to do is we're going to do a little substitution, kind of like what I did earlier, right? But it's a little bit more involved. Not much. It really isn't. It's not much more involved. It's a little bit. So do I kind of know what x is equal to or y is equal to here? Is there like x by itself or y by itself here? Yeah, which one? The x. The x is by itself, isn't it? So what I'm going to do is I'm going to take what x is equal to, and then I'm going to plug it in where? for the other x in the other equation. Exactly right. So since x is equal to this, and these two x's are the same thing, can I just replace this x down here with this x right here? Yeah? Carrie, you getting all this? It's good stuff. You're missing out. All right? So watch. I know. but I know that you want to learn this. I don't think he cares one way or the other. So I'm just trying to help you out. I'm not trying to get on your case. I'm just trying to help you. All right, so here we go. Let's do this. What are we going to do? I'm going to go 2 times. How do I show times? Put a what? Parentheses. And what am I going to put in for x? That's it. 2y plus 1. But let's finish off the rest of the equation. There's my 2x. Then I put equals. And then I put what? 5y minus 2. Now what can I solve for? Now I can solve for y. I got one equation, one variable. Now I can solve for it. Agreed? All right, now it's just basic, super basic algebra stuff. Give me a good math word for what we're going to do to this. What do we call that? Starts with a D. Distribute. Very good. It's distribute, so let's do that. That's 4y plus what? 2 equals 5y minus 2. And let's just get y by itself. Let's subtract a 4y from both sides. Let's put it over here on the right-hand side. Let's add a 2 to both sides. All right, let's see what we get. That cancels out. 2 plus 2 is 4. 5y minus 4y is 1y. That cancels out. So what's y equal to? It's equal to 4. Okay? We'll keep that. We'll circle it. It's not my final answer, because what's my final answer? I'm trying to find how long these sides are, correct? So what can I do with that y, though? Plug it in for this, plug it in for that, and I got these two sides. Agreed? Once I get these two sides, really, all I got to do, once I get a number for this, what's this side going to equal? Right, whatever this is, okay? So do I really even have to get x by itself now? Not really, okay, in this situation. But let's do it anyway, just for fun, all right? Because this is kind of stuff you would do in algebra class, so let's do it. So y is equal to 4. So now I can come back up to this one, or I could put it in right here if I wanted to. I'm going to get the same exact answer. It doesn't matter what equation. This one's way easier, wouldn't you agree? Because x is already by itself. Yeah, so I could put it in for this, all right, and then solve for x. You're going to get the same exact answer. So watch. X equals what? 2 what? 2 times 4, right? Because y is 4, correct? So 2 times y, which is 4 what? Plus 1. So x would be equal to what? 9. Okay? Yeah.
So you basically, okay, I'm just trying to make sure that I'm getting it.
That's fine. Go ahead.
So when there's a variable, like let's say if it was y, for instance, you would basically like switch it up. And
If it was y equals to something instead of x equals something, absolutely. I would have substituted the thing with the x in for the x on the other one. Yes.
Oh, okay.
All right, so the only reason that I substituted this in for the x is because x was sitting here by itself. All right? Right. Now, I could have solved for x here, but I had to divide by 2, and then I'd get a fraction. That'd be ugly, wouldn't it? I get 5 over 2y. Now, this would be easy, because if I divide that by 2, it'd be a 1. But still, do I want to do that? No. Could you do it? Absolutely. It would work, but it would be ugly. All right? It would be too much trouble. This is the easiest way to do it. And I always want to do it the easiest way, don't you? Yeah, of course, everybody does. All right, so I tell you what, let's not do the x's yet. Let's just do the y's, and let's see if it really works. Okay, let's put the y in for this. So y is equal to 4. So in your head, what's this side going to be, LM? 2 times what? 4, which is 8 plus 1 is 9. What did we say x was? Look at that. It works out, doesn't it? Works out perfect. It should be 9, shouldn't it? Because they should be equal to each other. And sure enough, we did the math correctly. So this is 9 and this is 9. All right. Let's do the y on this one. It'd be easier to do the x, though, wouldn't it? 2 times x is what? 18. So this should come out to 18 as well, shouldn't it? Let's just see if it does. So it's going to be, let's do it in our head. 5 times what? 4, which is 20 minus 2 is 18. And then, of course, we said that that was 18 because it's 2 times 9. But did I even need to go figure out what the x was? No, because since it's a parallelogram, I find one side, the opposite side's exactly the same thing. Agreed? All right. Well, that was kind of fun, right? Learning a new algebra topic. You guys never did that last year? Okay, now you did. It gets a little bit more involved than that, all right? But we picked pretty much one of the easier types of these to start off with, all right? So they didn't give you anything super tough. What's the other thing we haven't solved for yet? The what? The angles, all right? Now, let's take a look at this. They tell you this is 7a, and they tell you this is 13a. What do you do with those? Do you? Why? Are you just saying things because I questioned you? What's the relationship? You're the one that told me the relationship earlier today. Right. They're supplementary to each other. Look, the consecutive angles, the angles on a parallelogram that are next to each other, right? Do you see that? This one and this one are next to each other. They're always what? Supplementary, which means, what do you do with them? You don't set them equal to each other. You add them up and set them equal to 180. All right? Now, just take a look at it before you're quick on saying just set them equal to each other, because that's what a lot of people do. They don't know what to do, so what do? You set them equal to each other. Have you ever been in that spot where you're looking at them, well, I'm not really sure what to do, but he always says to set them equal to each other, so let's do it. Maybe that'll work. All right? But look, what kind of an angle is this? It's acute. What kind of angle is this one? That's obtuse. Is there any way you're going to set them equal to each other? No. Okay? You got it? Let's do this. This is really easy now. What's 7 plus 13? 20. 20a equals 180. Divide by 20. Divide by 20. What do we get? A equals 9. Very good. Because the zeros cancel. 18 divided by 2 is 9. It's not my answer, though, is it? I got to find all the angles. I found all the sides. Now I want to find all the angles. So how do I find this angle J right here? Plug it in. What is it? 7 what? 63. 7 times 9. That's 63 degrees. What about L without doing any math whatsoever? What's angle L equal to? 63. Now you could find this. Now 13 times 9. I don't know what that is off the top of my head. All right, but you could do this. If you know this is 63, you could do what to find this angle? You could go 180 what? Minus 63. If you think that's easier than going 13 times 9, that's fine. And what is this? What is it? 117. So this would be 117. So what do you think 9 times 13 is? 117. Exactly. All right. Now, what's K without doing any math at all? Is 117, because the opposite angles of a parallelogram are equal to each other. All right. I got about 5 minutes left, so let's do this one little thing. This is pretty easy. No examples for it. I'm just going to show you what the theorem says. All right. Everybody got all that down? Good. Let's do this. This will be the last thing, so don't pack up. Okay. Take good notes. I got some parallel lines here, so I'm going to copy and paste again. And I'm going to move this around to about right there. Move this to about right there. It doesn't really matter. Then I'm going to draw some transversals. So those are parallel lines, okay? I copied and pasted so that they definitely are parallel lines. So I told you right off the bat. All right, so you know they're parallel because I drew them that way. I told you that those lines are parallel. Let's put some letters in here. Put J, put K, and L. And this is P, Q, and R. All right? Now, here's what the theorem says. Actually, let me make this look a little bit better. I'm trying to split this, okay? All right, that's good enough. So, if I told you, this is what the theorem says, okay? I'm not going to really prove it or anything, but it's a theorem. Let's just believe it, all right? But you should be able to prove it. I just don't have the proof in front of me. I don't know. Maybe I could think about it, but I'm not going to. I'm just going to let you believe it, all right? So if I knew that JK was equal to KL, that's what they told me. They told me that was true. For instance, this could be 5, and then this is 5. What if they told you that those two segments are equal to each other? Gut feeling. What's your gut feeling about these two segments right here? That they're also equal to each other. Does it necessarily mean they're both equal to 5, though? No. But they are, excuse me, those two segments will be equal to each other, okay? Now, does that mean every time you have 3 parallel lines cut by transversals, those segments are going to be equal? No. It just means if they are. If these 3 lines right here are evenly spaced, and you have a transversal, and this segment JK and this segment KL, if they're equal to each other, that automatically means that any parallel lines that you draw through here, I could draw a parallel line here. I could draw a parallel line here. I could draw a parallel line, or not parallel. I keep saying parallel. What am I saying? Not parallel lines, but I could draw these transversals through here. So what's true about this segment and this segment? Those are equal, right? I'm going to put a whole bunch of these marks on here, right? Those are all equal. These are all equal. 3, what am I on now? 5? 1, 2, 3, 4, 5. That's stupid. But anyway, you get the idea. Does it make sense? So if one set are parallel, why do I keep saying parallel? If one set are equal to each other, then all the other segments are equal to each other as well. And that's what that theorem says, and that's it. How do you like that? A lot of stuff, isn't there? Did you ever imagine there's so much stuff to know about lines and all that kind of thing? There's a ton of stuff out there about it. As what? All right, here's your homework. I didn't give you anything last night, so you should be able to do this tonight. Excuse me. All right, everybody good? All right, have that done for tomorrow. We'll go over that tomorrow.